Hey everyone, so today we're going to be continuing with our intro to Arduino unit, and this is going to be part 3. So some essential questions that we're going to be answering during this lesson are: what are variables? What is their function in a computer program? We've heard of variables before in other classes like math, but how does that kind of relate to writing computer programs? How can we use code to allow a microprocessor to make decisions? Essentially, like we said last week, a microprocessor is really just almost like a brain. So, how do we code that brain to be able to make some decisions for us? And then, lastly, what is the serial monitor and how can we use it to print and record data? So, just a quick review from last week. Last week, we did go over a few new commands. So, I just wanted to quickly kind of review that for you guys. So the first one is the void setup. The void setup runs once throughout your program, and it's where you identify pins as inputs and outputs. When you start a computer program, the void setup runs once, and then you kind of proceed with the rest of the computer program. The only time the void setup runs again is if you download a new program or reset your Arduino. So just keep that in mind kind of as we're creating some new programs throughout this week. After the void setup, we have the void loop. The loop is what runs continuously after the setup. That's where you control the function of different pins on your Arduino board. So in your loop is the main kind of chunk of your program. This is what's actually physically happening during your program. We also have a command called pin mode. We write pin mode uh, with a lowercase pin and uppercase M for mode. Capitalization does matter, as I mentioned last week. Then we have a parentheses. You put the pin number, then you have a comma, and then you write the behavior. The behavior must be in capital letters, and that behavior can either be an input or an output. And this command is only found in the void setup. Okay, so you're really just identifying different pins as either an input or an output. For example, if we're kind of programming some sort of LED, that would be an output, right? You see the LED shining, it's the result of some sort of input, maybe a human pressing a button. So an LED would be an example of an output. And lastly, we have digital write. So the command digital write is lowercase digital, uppercase W. The rest of it is lowercase for write. Then again, we have the pin number. And then we have the state in uppercase letters. The state is either high or low. So if we wanted to turn on an LED, for an example, we would write the pin number that the LED is connected to, and then we would write high because we want that LED to turn on. Now, just note that we are using digital write. The command digital write can only be used for digital signals. Okay, so an LED is a digital signal. It's a digital output, so we would use digital write. So kind of getting into our new content, some new kind of commands here that's going to help us with our lab activities for this week. Like I said during the essential questions in the beginning of this lesson, we need to kind of learn how to declare variables. So variables are used to store information to be referenced and manipulated in a computer program. So it's just a placeholder, really. Like in math, we have X is a very common variable, or N is a common variable if you're trying to solve for some number. It's very similar within a computer program, but we kind of can create whatever placeholder we want. They help us label and keep track of data, and it allows us to store that data in the Arduino microprocessor memory. And the variables within the computer program are written before the void setup. So here on out, we're probably going to be using variables in every computer program we write. So we'll have variables first, then we have our void setup, and then we'll have our loop. Again, once you kind of initialize those variables in the beginning of the program, the microprocessor knows it until you either restart it or download a new program. So the most common, I would say, variable used in beginning Arduino lessons is called int. It stands for just integer. So this is kind of the syntax, what we would call it, of how you would write this in a computer program. You write int, all lowercase, then you put the variable name, and then you put the value that you assign to that variable. So I let you know of that down here. So var is the variable name and val is the value you assign to that variable. It's really hard to understand this without using an example. So I have an example down here. So if I was writing a computer program, I would probably use two just slashes, write variables up at the top, just so I know everything below are my variables. So if I write the line of code int green equals 2, what I'm really saying there is that the green LED is connected to pin 2. So in the rest of my program, instead of writing 2, I would use the word green. Okay, you're just saying that those two things mean the same thing. I could have written green all lowercase. I could have used just an uppercase G. It's totally up to you what you want to name the variable. Like I said, this is just an example. Second, we have int yellow equals 3. So that's saying that the yellow LED is connected to pin 3. Same thing down here, and I know you can't see it right now, but this little bar will go away in a second. We have int red equals 4. That means that I'm saying that the red LED is connected to pin 4. So let's see side by side what a code would look like with variables and a code would look like without variables. So on the left, we have a program with variables. So I'm using the same examples as last slide. We have int green equals 2. So the green LED is connected to pin 2. Int yellow equals 3. The yellow LED is connected to pin 3. Int red equals 4. The red LED is connected to pin 4. So I'm no longer going to use 2, 3, or 4 when I'm trying to reference any pin. Instead, I will use the words green, yellow, and red because those represent those pins, like we just said. So now let's move down to the void setup. I would write pin mode, red, equals output. If I didn't initialize variables in my program, I would really be writing pin mode, and red was 4, so pin mode 4 output. Okay, so instead of using the number 4 and having to kind of remember which LED is connected to which pin, you can just label really the pins. That's all you're doing is labeling to make it a little bit easier for you to understand your program. Then we have pin mode yellow, output. If I didn't initialize variables, that would be pin mode 3, output. Yellow and 3 mean the same thing. Here, it just makes more sense because you know that the yellow LED is connected to pin 3. So you kind of get the gist of the void setup. Then we have the void loop. So we have digital write, red, high. So I'm turning on the red LED. If I didn't use variables, and I know this is kind of not exactly the same here, but you get the gist. If I didn't use variables, I would write digital write, the actual pin number, and then high. Okay, so this just makes more sense. You're labeling, those labels can kind of be customized to you, be totally what you want, as long as they're consistent. So if I use all uppercase green here, when I write my variables, I have to do the same thing everywhere else. I can't then move on to lowercase. Okay, so once you initialize your variables, they need to be kind of consistent throughout the rest of your program. Another new command or set of commands that we're going to talk about are if statements. So this is where decision making comes in. So if statements within a computer program allow for greater control over the flow of code. and allow you to make something happen or not, depending on whether a given condition is true or false. So this is decision making. So just looking at this flow chart here, if A is true, then make B happen. If A is false, then make C happen. Okay, so it's really just looking to see if something's true or false, and then you program kind of those reactions however you want to program them. So let's take a look at an example, because it is kind of confusing just thinking about it. There are three different kind of types of if statements, more simple if statements, and then we get more complex. So this is the most simple if statement. So it's just saying if some condition is true, then do this. Okay, so that's just plain if. Then we have if else, which is probably what we're going to use a lot. So if some condition is true, do this. Else, so if the condition is false, do this. Okay, so you're telling it to look for true or false, and then you're giving it two kind of options to go from whether or not that condition is true or false. Then we have if and else if. We're also going to be using kind of this style of code a lot. So because you're introducing multiple conditions, and a lot of time we have multiple conditions. So if condition 1 is true, do thing A. Else if condition 2 is true, do thing B. If neither condition 1 or condition 2 are true, and it's some other condition, do thing C. So you're kind of giving the computer 3 options instead of just 2. And in this kind of format of if statements, you're only giving the computer 1 option. Okay? So you don't have to do, or you don't have to have just 3 options. A lot of times you can do if condition 1, do thing A. Else if condition 2, do thing B. Else if condition 3, do thing C. Else if condition 4, do thing D. And you can go on and on and on and on. However many conditions you want to kind of put into a program. So let's take a look at an example. So this is just a regular if statement. So if the button is high, so if the button is pressed, and I wrote that here, if the switch is high, push down, change the lights. So if the button is pressed, turn the green LED off, turn the yellow LED off, turn the red LED on, and wait. And that's 10,000, so that's wait 10 seconds. Okay, so that's just a simple if statement. If button is pressed, do this. Simple. Okay, so we talked about if statements. We also have to talk about analog read. So we haven't introduced any analog commands yet, so this is going to be our first one. Remember, we've only done like digital write to turn on some sort of LED. So analog read reads the value from the specified analog pin. So it's similar to digital read, like we would use for a simple push button switch, but this is when we're introducing some analog signals. So the pin number can only be one of the analog pins on the Arduino board, and those pins are A0 through A5. There's only 6 analog pins on the Arduino board, so it's just important to note that. Examples of things that could be used, or components that can be used with the command analog read, are a potentiometer, right? You can change the dial of the potentiometer to give a different kind of reading of resistance. You can also use analog read with an LDR, light dependent resistor, or a photoresistor, a photocell. They all mean the same thing, because you can have a varying resistance coming from that light dependent resistor depending on how much light is on it. And then also any type of sensor. So if you're using a temperature sensor, a humidity sensor, any of those can kind of be used with the analog read command. So just some example code, because I like to give you guys some examples. This code reads the voltage on an analog pin and displays it. So we haven't talked about the serial monitor yet, so don't worry about any of the serial monitor commands, but I just wanted to give you kind of an example. So here we have our variables. So you can see that I named analog pin A3. So that means that the potentiometer, because that's what I'm using in this example, is connected to analog pin 3. Okay, so whenever you're using analog pins, you want to put the A in front of it. If I wrote analog pin equals 3, the computer might think that I'm referencing a digital pin, and you don't want it to get confused. You have to tell it exactly what pin to kind of look at. Okay, and then we come down here and we have analog read, analog pin. Again, we're using variables. If I didn't have a variable here, I would write A3, right? But we already initialized a variable here saying that analog pin, the word analog pin, is equal to pin A3. So we have analog read, analog pin, that's reading the value from the analog input, or pin 3. Analog read is only used with some sort of input. So like we said, a potentiometer, an LDR, or any type of sensor, giving information from the physical world to the computer. Okay, the last thing that I want to touch upon is the serial monitor. So the serial monitor is a separate pop-up window within Arduino. So far on Tinkercad, we've only really looked at like the physical Arduino itself, the circuit, and then the area where we write code. But now we're kind of introducing another kind of thing into the mix. So the serial monitor allows you to both send and receive messages from the Arduino. So you're actually seeing something happen. You're getting some sort of data. It's typically used for debugging programs or gathering data, like I said. So a lot of times, if you're trying to like take a reading from a potentiometer, take a reading from an LDR to see kind of the value, sometimes you'll use a serial monitor to get those readings and see if your circuit is built and your program is written exactly how you want it to work. So just some serial monitor commands. There are 3 associated with the serial monitor. The first one we have is serial begin 9600. This is a command that never changes. Anytime you're using the serial monitor within a program, you must have this command in your void setup. Okay? I'll make sure that I, remind you guys of this since this is new. So this command essentially just starts the serial monitor and sets the data rate, okay, how fast the data is coming in. Then we have serial print. This command is most of the time located in the void loop, but can also be located in the void setup. This prints data to the serial port as human readable text. Okay, so, and I'll show you some examples in a second, but this, places some words or places some numbers to information that may not be able to understand by humans. And then very similarly to serial print, we have serial print LN. Okay, we probably use this one the most. It's used when text must be printed and then the invisible cursor moves to the next line so that the next print statement will print text on a new line. I know it doesn't make a lot of sense right now, but I'll show you some examples. So just looking side by side, also this is how the serial monitor will look when you are in Tinkercad. So when you're on your code, you have your code up at the top, and then there's a little button you can press to show the serial monitor, then the serial monitor comes up. So essentially we have the same program on the left and on the right, just one's using plain serial print, and the one on the right is using serial print LN. So let's look at serial print. In the void setup, I have serial begin 9600, right? That's standard, that doesn't change, that must be in there. Then I have my void loop, serial print hello, then serial print world period, delay 1000. So that would look like this on the serial monitor. Hello world, hello world, hello world, hello world, going across horizontally. So like I'm almost writing a sentence. Okay, that's just plain serial print. Now let's look at the right. Again, void setup is the same. Serial begin 9600. You must have that in the void setup if you are using the serial monitor. If you don't have that line of code, your serial monitor will not work. It won't show you any data. Then we have the void loop. Serial print hello world, hello, right? So that's on one line. And then we have serial print ln world, period. If we have the ln, we move the cursor down to the next kind of line, right? So hello world, period, should all show up on one line, and then we move kind of enter down. If you're on a Word, if you're thinking of like a Word document, when you press enter, you move down to a new kind of line in that Word document. So it would look like this, okay? Everything would kind of be written vertically. Hello world, period, move down to the next line. Hello world, period, move down to the next line. Okay? A lot of times it's hard to kind of understand information when it's going all the way across like a sentence, right? Horizontally. If we were trying to gather a lot of data about certain numbers, it would be hard to understand those numbers if it's written all the way like a sentence kind of going horizontally. It would be much easier if we could just scroll through the serial monitor and have each like line of data printed on a new line. I know I'm just using hello world as an example here, but I think this does a nice job of showing you the two differences.